In the last video, we talked a bit about declaring variables and some of the data types that came with variables. In this part, we'll actually talk about how to use them, specifically the numeric types, the integer, and the float, and how to do arithmetic operations on them. So, an integer, like we said in the last video, is just a counting number, right? So that's something like 1, 2, 3, 0 as well counts, and so do negative numbers. So -2, -1, 0, 1, 2, 3, etc. in both directions is what integers are, and floating points include these numbers as well as things like 3.14 or 2.6 or -7.3. So floating points are data types that can have fractional parts or a decimal part after the actual integer part. Now, we want to be able to do math on these because that would help us quite a bit to actually solve problems, and pretty much every programming language, C++ is no exception, supports operators for both of these. So of course they both support plus, subtraction, so minus, division, so you'll notice that division is done with the slash. It's the / on your keyboard. We don't use this symbol since it's not really on the keyboard. We'll be using the slash instead. And then same thing for times. Instead of using a dot or an X, we'll be using the asterisks on your keyboard, and that will mean times. Now you'll see that the integer actually has one extra operator, and this one is called modulo, and we'll get into that in a second. Now, adding any two data types that are of the same type will work pretty much as you would expect it to. So if I took 3 plus 4, then both of these are integers, right? 3 is an integer and 4 is an integer, at least by default. And if I try to add them together, I will get another integer. And same thing goes if I add two floats together. So if I did, let's just say 3.2 plus 4.6, I will get something like 7.8. And again, these two things are floats. And their result is also a float. Now, we don't normally think about it when we do actual math, but we need to address what happens when we add an integer to a float. Because in C++ and many other languages, we have these defined types, an integer and a float. So even though they're both numbers, they are different data types, right? The computer recognizes them differently, it stores them differently, and it's able to do different operations we see here, which we'll get to what the modulo means in a moment. So it's important that it knows how to add an integer and a float, and it has a consistent data type to store it as. So if I do any sort of arithmetic that involves a float or something similar to a float, like a double, then what it will do is it will coerce it. And what that means is that it will automatically convert it to a float if any integers are involved. So if I did 6 plus 3.2, then we know that 6 is an integer, and 3.2 is a float. Whenever you do this, the computer will automatically determine that it needs to make the answer a float. And it kind of makes sense here, right? Because if you were adding this normally with your normal math, then this would be 9.2, right? Which is also a decimal, which we said is called a floating point type. So whenever you add an integer and a float, or multiply, or divide, or subtract, any of those operations, it will coerce it. And coercion just means that it will change the type to a float rather than keep it as an integer. And it actually does that before it does the addition, so it will first convert this int to a float, and then it will add the two floats as it knows how to do already. Let's just do a few more examples here. So it's kind of important to consider the fact that this happens, because if you want to do integer division, then you're going to need to do something special, and if we want a number to be a float, then we're going to need to do something special as well. Okay, so we've covered addition now. Let's get into the other operations. Specifically, I think division is the most interesting one. Now, if I did division with floats, then it's probably exactly what you would expect in terms of the way that normal mathematics works. So here we have 3.0 and 4.0, which are both floats, and if I do division between these, you would get 0.75, right? So again, kind of like we set up here, when we do an operation between two floats, we get another float out. And if we did the same thing with integer and a float, we would also get 0.75 because of that coercion that happens. So remember, whenever we have an integer and a float together, then it will coerce the integer to become a float and then perform the operation as if they were both floats normally. But we wouldn't get 0.75 if we did an integer divided by an integer. If we did 3 divided by 4, where both of these were integer types, what would happen is we would actually get 0. And the reason is because it can't support 0.75, right? If we do an operation between two integers, we expect a third integer out. And now you might be wondering, why is this 0 and not 1? 0.75 is closer to 1 than it is to 0, right? So definitely isn't doing something with rounding. And you probably have seen the way that this works before in maybe grade school, but they don't necessarily always do it this way. Now, what we can say about 3 divided by 4 is that it's actually 0. So 3 goes into 4 0 times, and it has a remainder of 3. Right? So you might remember there's a remainder division, where instead of doing it strictly with a decimal number, we can do it with how many times does it go into it, and then what's left over. So here, what we actually get is the 0. That's the result of the division. And we have another operator to get the remainder part, which is called modulo, and that's done with the percent sign. And so if I did 3 modulo 4, I would get the 3, the remainder part of that. So, just for an example, if I had 15 modulo 4 and 15 divided by 4, let's do this in the reverse order, just so it's easier to see. Divided by and modulo. 15 modulo 4 is 3, because 15 goes into, other way around, 4 goes into 15 3 times, and 15 modulo 4 would be 2, because it would have a remainder of 2. So if we just draw that out really quick, so it looks something like this, right? If you remember some of your math from grade school, then I have 15 squares here, right? I have 1, 2, 3 many ways to do 4 groups when I have 15 blocks, and then I'm going to have a remainder of 2. I'm sorry. Oh, it is a remainder of 3. Perhaps this was a bad example. Let's do 14 instead, so that it works out to be different. 14 divided by 4 is still 3. 14 modulo 4 is the 2 that I wanted. And you can see we do have 14 here, right? There's 12 blocks on top, and then 2 here for 14 total. So modulo represents the remainder that we would get from doing division like this. And normal integer division does the normal division. So the thing to take away from this is that integer division is different than floating point division. Floating point division gives you an exact answer, whereas integer division gives you the division and then the remainder. And another way to consider the division for this is that it is always the floor of whatever you would get from doing the division with floating points. So here we said it wasn't actually rounding up, right? It doesn't do any sort of rounding with the number, but we know that 3 divided by 4 is 0.75 in the traditional sense. So what it does here is it actually just truncates this float, or one way to think of it doesn't actually do it this way, but it will truncate this decimal part. So if I was to take 3 divided by 4 and just throw away everything that came after the decimal, I would be left with 0, and that's exactly what 3 divided by 4 with integers is. And that'll always be the case, right? 14 divided by 4 is 3.5, I believe, right? So it would be just 3 because we would throw away the 0.5, and the 0.5 gets captured in the remainder part. Now just for one last example here, something nice if you haven't taken a course on modulos yet is we want to consider how modulos work with negative numbers and then just see kind of the pattern on how they work. So here, let's just do a bunch of different numbers. So I will throw a bunch of numbers, let's just call them x. And then here we'll have the remainder y, or sorry, r. We'll just call it r. And we'll do all of these modulo 3, let's say. So if I took 0 modulo 3, I would get 0. Because 0 divided by 3 is 0, and there's no remainder on top of that, right? If I did 1 modulo 3, it would be 1. If I did 2 modulo 3, it would be 2. And if I did 3 modulo 3, I would get 0. And the reason being is because 3 divided by 3 is 1, and it would have a remainder of 0 left over because 3 goes evenly into 3. The thing to note here is that if a number goes evenly into another number, then its remainder will always be 0. So if we want to check how numbers go into another number, or if they go into another number, we can always check if the remainder is 0. Now if we were to keep going here, I'll just go up to 6. We know that 6 is the next multiple of 3, right? So we expect its remainder to be 0 again. And if we keep going here, 4 modulo 3 is 1, because 4 divided by 3 is 1, remainder 1. 5 modulo 3 is 2, and 6 modulo 3 is 0, because 6 divided by 3 is 2, and the remainder is 0. One other thing to note about this is the fact that the pattern always repeats. So it will always go 0 and then count all the way up to 1 less than the number that you're moduloing by, because once you hit a full number, then it evenly goes into it, right? Once I hit 3, then 3 divided by 3 is 1 with no remainder left over. So this pattern is going to keep repeating forever and ever and ever. We'll always get 0 up into the number minus 1. So here we can see we go from 0 to n minus 1, where n in this case was 3. So something to keep in mind about that is that we know it will always go to 1 less, and we can use that for some problems in the future. Alright, so let's do an example of where this might come into play. So let's just say you want to check, is a number even? Let's go ahead and program this. So let's swap over to Visual Studio really quick, and I'll just add on to what we had in last part. What I'll do here is I will create a variable called int number, and I'll just set it to whatever we want. So here, let's just say 6. And then I'll create another one called int number 2. and we'll set this one equal to 9. So the first one is even, and the second one is odd. What we want to check is whether or not this first one is an even number and the second one is an even number. So what we said with the modulo was that if a number goes evenly into something, then its modulo is going to be 0. The way we can do that then, if we want to check an even number, is that every even number is divisible by 2, right? So if I want to check if number is divisible by 2, and if number 2 is divisible by 2, then I can check whether they're even or not. What I'll do for now is let's just do a single variable and we'll just print it out. So remember, we can print with cout, so I'll do cout, and then I will do number modulo 2. And for now, I will leave it at just that. We'll explain how we would check it in the future. If I run this, I should get 0. It does take a second. And here we go. So we run it, we get, oh, I hit the button a little too fast there. We run it and we get that the last output, so these were from our last program, we get that the output is 0, which is what we expected. So if I was writing a program that checked if this was even, then I know that this number is even because its output was 0 when I modulo it by 2. Now if I do a number like 7, and I rerun this really quick, so let's just close this one and rerun it, you'll see that the answer we get is 1. And that would tell us that the number is odd, which 7 is odd, so that checks out. There are a lot of other ways that you can check this, with the key point being the fact that this repeats, is that we can always keep track of how many times something has repeated and how far it is into repeating as well. And we'll get into some more practical examples of how we'll use that when we get into stuff like arrays later. Now, the last thing I think I wanted to address, for modulo at least, would be how to do modulo with negative numbers. So if you're already familiar with negative numbers and their modulo, just know that the way it works in programming languages is generally a bit different than the way it works in math. Let's just do an example really quick. Here I will make this -1, and we'll do a modulo by 2. And you'll see that we get -1 out. Now if I do it with -3, you'll see that we get -1 out again. So you might be noticing 1 modulo 2 is 1, and 3 modulo 2 is also 1, and so it seems to just be the negative version of the modulo. Right, so -3 modulo 2 is equal to -1, -1 modulo 2 is equal to -1. If I did 3 modulo 2, we know that's equal to 1, and 1 modulo 2 is equal to 1. So if I was to keep up this pattern with some other examples, then something like 4 modulo 6, if I did -4 modulo 6, it would be -4, and if I did let's just say 9 modulo 6, then it would be equal to -3, because 4 modulo 6 is 4, and 9 modulo 6 is 3, because 9 divided by 6 is 1 with a remainder of 3. So when you do programming, the way it does modulo is it just does the modulo of the unsigned version, the positive version, and then it just negates it. If you're familiar with math, that's not the way that works, right? The way it works is it generally subtracts this from 6. So normally -9 modulo 6 would be +3, and -4 modulo 6 would be 2, because it'd be 6 minus 4. So just something to keep in mind if you're already familiar with the math way that Modulo works is it does work a little bit different in programming languages, and if you want it to have the normal math behavior, you do have to program it yourself. Okay, the last thing we'll talk about is casting, which is basically like that coercion that we talked about, but when you explicitly do it yourself. And there may be some cases where you want this. So earlier we said something like 3 divided by 4.0 would give you 0.75 if you typed it in. And the reason it does that is because 3 was an integer and 4.0 was a float, and so it picks the one that's higher, has a higher precedence in terms of that of coercion, which a float has higher coercion precedence than an integer. And there's a whole table of that, but I think we'll skip that for now. That is maybe a little beyond the scope of this course. But let's just say we wanted to do the 3 divided by 4. We know right now that that gives us 0, and then the remainder of 3, right? Because we said that integer division always gives us another integer out. But maybe I'm doing a program where I've declared something to be an integer. Let's just say integer x equals 3, and integer y equals 4, and we want it to be 0.75 rather than 0 that we have. So if I went down here and did C out x divided by y, what this would print is just 0. But maybe I want it to work the way that floating point numbers work. And so we maybe need a way to do that rather than just introduce a float in there. So there are 2 different ways to do this. One way would be to introduce a float, which is the way I don't recommend doing it. So one way to do it would be to say I could do 1.0 times x. We don't necessarily need these parentheses, but it is there, divided by y. And if we consider what this would do, is this is a float, and this is an integer, and this is an integer, right? What it will do is it will go left to right because we have multiplication and division. So another thing I think to note is that when we do arithmetic in any programming language, it will have precedence rules for these operators, and if you're unfamiliar with what that means, basically it does order of operations. So it will do parentheses, exponent, multiplication, division, addition, and subtraction. Whenever you do arithmetic, it'll basically just obey the exact same way that you would write it when doing, normal math. So if I did 3 plus 4 divided by 2, then it will do 4 divided by 2 before it does 3 plus 4. We'll do another example of that in a moment, but let's just finish this one up. What this will do, though, so we were saying we want this to be a float output rather than an integer. One way to do that is to just multiply by the number 1.0, and that will work because a float times an int is a float, right? So this will multiply x by 1, which is still x, right? But it will change it to a float because it's doing float by integer arithmetic. And then it's going to do a float divided by an integer, which is also a float. So this will give you a float output, and it will give you 0.75 if I did it here. But let's try not to do it that way, and the reason I say that is because multiplying by 1 takes an extra step that we probably don't want to waste. Another way to do this is with something called casting. And the way we do casting is we just put parentheses and then the name of the type that we want it to cast to. So here we want a float, and then we can simply cast one single variable to that type. What I'll do here is I'll cast x to a float, and then I'll keep y as an integer. And what this will do, so this will print 0.75, and we'll take a look at it in the actual code here in a second. And the reason it will do that is because this casting part right here, when I write this parentheses float, it will turn x temporarily, at least for just this line of code, into a float, which means that now when it does this operation, it will do a float divided by an int. And as far as our order of operations go, the float, the casting, does always come before any sort of arithmetic operation. So all cast will be done before it does any sort of actual adding, subtracting, dividing, multiplying, and times. So normally they teach you PEMDAS, right? Please excuse my dear Aunt Sally, parentheses, exponent, multiplication, division, addition, subtraction. Because we have more operations in programming languages, those also go in our order of operations, and we have a whole list or like tree that you could check to see it. The casting here comes before parentheses. So just something to consider. So casting will always happen first. And this is called a cast. Right, so this will give us a float. Let's just see it in action really quick, and then let's go over just order of operations, and then I think that will about do it for the arithmetic operations. Let me quick print whether a number is odd. Let's turn this back to a positive just for later. Now, let's do an example where we do int x and int y, and I'll set that equal to 4, and I'll set this equal to 3. What I will then do is let's see out x divided by y and end line. So that starts a new line, right? And then we have c out. In fact, above this, let's print an extra line just to make some space. C out float x divided by y. And so again, what we said is that this one will give us 0.75 because it will turn the x into a float, which will be 3.0, and then divided by 4. And this one will just do 3 divided by 4. And then let's throw out a little bit of a string in here too. So let's put x divided by y equals. I'm not sure if we've done this yet, but you can put a message, a string, with a number whenever you see out. So here I put a string, and then if I just separate it with the extraction operator, the 2 arrows, you can keep going and put as much as you like. So here it'll print this message and then the number. And then we will do float x divided by y equals, and we will see what we get. I'll throw an end line here. Okay, so we compile it and run it, and I made a mistake somewhere. Identifier C is undefined. On line 7, I may have made a typo. Int x, oh, whoops, I named x up here and y up here, and then I did it again down here. Let's call this m and n then really quick. So let's change the name of the variable. I guess that's a nice thing to know as far as our errors go. You can't rename a variable and just use it again, at least not in the same scope. So I had x earlier from the program that we wrote in the previous videos, and then I tried to make it again down here before I changed it, and it did not like that. Now, I don't know where this is coming from, but if we run it, we should be okay. All right. And you'll see that exactly what we said. M divided by n is 0, and m divided by n casted to a float first is 0.75. So if there's ever a case where you want the number to be a float instead of an integer, even though you're using integers with your operation, you can cast to a float and it will cast it there as well. Now it's important that you do the cast before the division and not afterwards. And just to show that, let me do an example here. So if I did float, and then I did m divided by n first. So just like in math, we can put parentheses around this, right? And it will do the thing in the parentheses first because that's how the order of operation works. So I know I did say casting comes before the parentheses anyways, but it kind of depends. If there's an operation that still needs to be performed in the parentheses, it will do it first. So this will do m divided by n, and then it will cast with a float afterwards. And we'll just type that out. So let me just copy and paste it. I think that's easier. we'll just copy and paste this. So if I do the cast to a float after the division is done, what we'll get is actually 0 rather than the 0.75. And if I run it, we should see that. And we do, right? We see that it's 0. And the reason that is because it will do the integer division first. It will do 3 divided by 4, which is 0, and then take that answer, which is already 0, and then cast it to a float. So if you're going to do a cast, make sure you do it to an individual variable rather than the result, at least if that's what you're intending for your result to be. I think that about does it. We'll just end on one example really quick here with order of operations. So I'm assuming that you already remember most of your order of operations from math, but just as a refresher, if I was to do 3 plus 4 times 2, then the way this will work is exactly the way it works in math. It will do 4 times 2 first, which is 8, and then it will do 3 plus 8 afterwards, which is 11. If I want it to go left to right, then I actually have to parenthesize it. So remember, we do multiplication first and division first before addition and subtraction, no matter what. But if you want this to go left to right, which might be another way to read it, then we can do it with parentheses. So you'll always need to do 3 plus 4 and then times 2. When you're writing in C++ or any other programming language, you do always need this times. So just consider, if you're familiar with math and you try to do this where you just put a parenthesis next to something, we just went over the fact that the parentheses actually does casting. So even though this isn't a type, it's not the word float or int or something like that, then it is still going to interpret it as casting. It's not really going to make sense unless we put an operator. So you do always need the times symbol. You can't just get away with putting parentheses like in normal math. But anyways, this will do the 3 plus 4 first, which is 7, and then it will do the times 2 afterwards, which is 14, right? So if you want the order to go out of the order of operations, make sure you parenthesize it. And last thing, we went over earlier how to cast a integer problem to a float problem, but you can also do the exact opposite too. So if I had a float called x that was equal to 3.0 and a float called y that was equal to 4.0, and instead I wanted this to be 0.75, or sorry, instead of 0.75, I want this to be the 0, and I want to be able to do the remainder, then the way I would have to do it is, we said the only way to be able to do integer division is when both arguments are integers, right? So what I would need to do here is I would need to cast x to an integer and y to an integer in order to get 0.75. If I only made x an integer or only made y an integer, then it would have done an integer divided by a float or a float divided by an integer, which would still give us a float. But if I do it this way, then we get 0 like we have here. Right, so whereas in the previous example, we were able to just cast m to a float and then n we could keep the same, although it would work still if I did this. If I made n a float, it would still be a float. Because float has a higher casting priority than int does, then I only need to do it to one argument. But if I want to go the other way around, like I did in this other example, then I need to make sure that I cast both parts to whatever the lower thing is. So here it would be an integer. I think that about does it for arithmetic operators. In the next part, we'll do an example, just throwing everything we've learned so far into one concrete example and how we would use it.